1, 2, 1, 2. Awesome. That's gonna work. Welcome to unsupervised broadcasting. Sorry we missed last week. We had a bit of an issue with work, so we're catching up this week. This week, surprise, we have zero fan mail. We have absolutely no followers, so wonderful. Welcome to the internet. So since we missed a little bit of last week, we'll do a little bit of news from last week. This one's kind of interesting because it's progressed a little bit since last week. So last week the Canadians started holding up the border. Did the math to find out about how much in financial blockage they were stopping. It was approximately $10 billion per week that they stopped it. So I thought that was kind of interesting because the truckers were like, well, you know, you're going to try and lock us up. Let's see who locks up who. They go and they lock up the border and all the highways. And I thought it was a pretty interesting play for power and control. But then the Canadian government comes in and is like, well, we're going to slap all y'all with a $100,000 fine and a year in prison. So who's playing who as far as power and control in that realm? So we'll see how that plays out and how the rest of the world feels about that. That feels pretty intense to me, but you know, I'm not here to give the opinions. The other one that is interesting on news is this one's technical and more happy. It's the Mars rover 1 year anniversary. So I thought it'd be kind of neat to take a view. NPR had a really cool view as far as what the map looks like, so you can kind of see where on Mars this thing is tracked. So you can kind of see the in focus and out of focus regions. This in focus section is obviously where the rover has gone and seen some more details. It is cool, you can zoom in on it and everything. So, you know, here's a crater that this thing has gone to, and right now, after a year, it's discovered a whole lot of space, and it's kind of hanging out over here, it looks like. Oh, that was something else. I didn't know this, but they launched well, they call it a helicopter. I think helicopter is a little ambitious of a term for what this thing really is. I would argue that it's more of like a sophisticated drone, but, you know, go on NASA, call it a helicopter, whatever. I'm just happy y'all are going to Mars and finding stuff. And last but not least, I thought it'd be kind of cool. This is amazing. Like, for somebody who works in communications and technology, seeing that they're pulling this kind of high quality footage. I mean, dang, I can't even get YouTube to stream properly. Look at what NASA's doing. Like, this is, you know, their stream from the Mars rover, and they're pulling all this imagery. Now, of course, they're doing it like probably slower in molasses, but who cares? Like, look at that. You pulled that from freaking Mars. Man, science is amazing. Keep going, guys. Like, that's awesome. We were going to add a new segment to today. Let's go ahead and pause this guy. Hit this back up. I got me this. This is an awesome book. That's interesting. When you put it in the camera, it makes it look like stars. It ain't even green. It's yellow. Okay, well, that's fun. So we're going to do a couple jokes out of this thing because, you know, that's kind of fun. And in the spirit of computer engineering, they're all computer jokes. So as a dad, I'm allowed to do as many bad jokes, and because they gave me the power to stream whatever the heck I want to the internet, why not? Like, let's just read some jokes. So we got one. How are computers like hallways? They both have monitors. These are perfect. This is the best kind of joke. Why did the disk drive become a professional goalie? It kept making great saves. Why did the microprocessor always write form letters? It was an impersonal computer. That's funny. Why shouldn't you let your computer drive? Because it might crash. Those are great. Well, we're going to save more for later. We got to keep, you know, maybe we'll just turn this into reading jokes for a while. I heard there was this YouTube lady who does nothing but study, and people tune in and watch her, and she's got millions and millions of views. I mean, gosh, I'm going to try and put something useful together here and funny, and this lady's just sitting there studying. Whatever. Mine's probably not that interesting either. I still got no fan mail, no fans, so who knows? And we're going to go over something I learned this week because that's important. So, work in engineering, software engineering. I've got a project that I've been working on with a startup. It's not my day job, it's a night job. And one of the engineers was working on some code. Just in case y'all didn't know, we're doing basically super massively parallel processing. 10, 20,000 stock symbols every single day. And there's a tenet in multiprocessing that you really need to follow, and it's stateful, or I'm sorry, not stateful. That would be terrible. You don't want stateful. You want stateless, immutable, and separation of concerns. And all three of those were broken on a piece of that code. To try and explain this a little bit better, I'll go in and kind of show the place in the code where it kind of surfaces, and kind of, if you're looking at a code base, how you might be able to try to identify this pretty quickly. Let's see if this thing will switch up. All right, so here's some code here. And this here, man, okay, this is Python. You might have another language, but Python tabs matter. C# tabs don't matter. It'll probably say like global or something like that next to it. It says line 59 and 58, and also 60. All three of these lines. These are big hints that there's something bad going on. But in particular, this one here, I don't like global objects, especially in something that is supposed to be doing like parallel processing. So this is in our ingestion orchestration engine, which does a lot of parallel processing. And here we got ourselves a global object. And then if we go and just kind of like, find all references to this thing, man, this thing's everywhere. This is a bad day. Not only is it everywhere, it's like it's in a lot of different files. So it's in this file that actually does the processing, and it's in the orchestrator file being used, and then it's in this other one. Oh, that's a test file. Okay. Well, nobody cares about unit tests. So I'm going to I tried to draw this in PowerPoint because trying to go through real code to look at this is really challenging. Here's kind of like a basic dummy version of what this thing is doing. Or like presenting the anti-pattern, like why is this really bad? Basically, like we're processing a giant freaking list of stock symbols. It's a list of objects. Objects have properties on them. Ours have like price, company name, like financial reports, etc., yada, yada, yada. And really what it does is it goes through and it just spits out processes, and each little thing processes it. So this is kind of like the orchestrator. This is kind of like that global object over here. And this one here is kind of like the individual object. And then this is kind of what the object sort of does in some way. And what this is really saying is that we are modifying the object based on some kind of calculation using the other objects. And we're doing it kind of in sequence here first off, which is also bad. I'm not sure this is the best to reference because we're kind of modifying. Really what he's doing is this. I was really going after that it's modifying it, but I guess I also did a bad calculation. This calculation needs to be done sequentially and probably in batch as well. So anyways, maybe a bad example. But the point being that we're modifying the underlying object, which is shared across each one of these processors. One, that's not even physically possible for most of the time. Like in our actual processing engine, we've got like, I don't know, 20,000 symbols. I think we have 500 to 1,000 computers in the cloud that actually do this, and they're not connected to each other, so like they can't share memory to begin with. So like that's just not even physically possible. So like trying to modify it and then expect that it's going to, each process is going to know what the modified value is, like it ain't doable that way. So you have to come up with a different way to do it. Yeah, and then we kind of exacerbate the problem even further if we do like a parallel for each. So if each one goes off independently and then you collect at the end, like the problem becomes even worse. One, it's an order of operations. Like, did the last one go first? Did the first one go first? I don't know how fast the computer we decided to stick it on was. Like, it's just kind of getting shoved onto random computers, and they're being shoved on at random speeds, and the random computers with random computing capabilities. So I don't know which one's going to go first. So you kind of got a guarantee around that. And then if you end up doing any of these together, so the more parallel tasks you throw at it, if you're sharing these objects and you're expecting to maintain state in these shared objects, it ends up being a really bad idea. You get a lot of issues, exceptions, calculation issues. So you really want to be as atomic as possible, and you want to be as stateless and immutable as possible. You don't want to change any of it. Try to make all of your calculations not require like state to be shared between other processing components of the calculation. It's just a general anti-pattern. So we kind of discovered this, and luckily all this stuff is fixable. So you can just go in, and we changed it so that now it just sends an exact copy of the list, and anything that needs to be modified is being pulled out, and then it's being sequentially executed. So like in this kind of code where you're running them back to back like this, because we're doing parallel, this kind of like, hey, you need all the information to begin with, gets parallelized. So you'll see like in, that's the UI, in our code here, and we go to our orchestration engine, you'll see that there are a couple sets of calculations that end up being parallel and some that end up being sequential. So this whole initial ingestion of all the data from the Securities Exchange Commission, this ends up being done sequentially. We just want to get the core information in, and well, no, it's done first, and then everything that needs all the information, because all of these need all the information, but they need all the information kind of independently. So you have the ability to do immutable, stateless processing here. So I wanted to talk about that because it's a super complicated topic. So trying to do this in a matter of 2 minutes is challenging, to say the least. You could write a whole paper on this, but the main thing is that if you're going to write parallel processing code, like, it needs to be stateless, it needs to be immutable, and please don't like have code kind of crossing boundaries. Like, you'll see that another mistake that we had in here was that the code, this here lives in this data ingestion orchestrator, but the actual object itself is inside this other path. Oh, I'm sorry, the reference to it. So the object lives here inside of something that's supposed to be completely and 100% isolated, but there's an offending line of code up here. I think I marked it as line 70. Yeah, here it is. See, it's pulling the static objects. Super bad. So that was the issue. Alright, we're going to go back to this camera view. So, other item on the list, something challenging from this week. We'll talk about leadership. So, this comes in a couple forefronts. I have a lot of leadership responsibility on the day job. I got a lot of leadership responsibility on the night job. And as you get further along in your career, and you're going to have more people who are wanting to help you. You end up doing a lot of stuff initially, and you are the person physically doing all of the work. And you build up a great reputation doing that, and then you get more and more things coming in, more and more work. And then it's a matter of you don't have the capacity to do this anymore. And you need to then make sure that you have people around you that can do those works, and you can help lead with solid strategy. And what the challenging thing from this week is I've been able to successfully surround myself with all of these wonderful people who can do a lot of that work, and I can, give great strategy. But I find myself, like, because a lot of my success has been built on like me physically going in and doing it, is that I find this tendency to want to jump in and physically do it, and this is super detrimental. You definitely need to have that background of having been able to do it, but like if you keep jumping in and doing it for your people, then they're never going to have opportunities to grow, and then they're going to look at you more negatively. So um, you're also going to lose a bunch of your bandwidth. So half the reason that you bring these people in to help you do stuff is so that they can do stuff. And every time you jump in and do a task that they could have done and done well and effectively is an opportunity that you just took from yourself to provide better guidance and grow the business even better. So something just to think about, it's at the top of my mind, is that like this transition from being just an engineer who does their own engineering, who writes code every day, to becoming an engineering leader running a fairly sizable discipline and a small company. That's a very hard thing, and it requires a lot of focus to do. So I want to call that, and it's not just engineering either. Like with the day job, it's all just engineering. But with like the startup, it's like, okay, we need to do marketing, and you find somebody who's valuable and powerful at marketing, and you want to be there and put your every little freaking stamp on every little aspect of it. And every time you try to put that stamp on it is time that you just wasted because you brought somebody in who specializes in marketing. You know they specialize in marketing. You know they know what they're supposed to do. And okay, it's not exactly perfectly right. Give them your feedback. Let them know that, you know, you'd like to have it done a little bit better. Make sure that they feel valuable and stuff so that they don't just like quit on you, especially today. Like, you don't want nobody to quit on you. That's really, you can't replace people very easily. And then like let them go and keep providing strategy and insight. So you spend all your time mostly trying to grow and tweak your people, as opposed to you trying to override and do things yourself the way exactly that you want to do it. You just need to make sure that you're clear and communicative with them. All right, other cool thing, we're going to end on something challenging from the week, is we're going to do a startup update, because that's super cool. We're going to go back to this. I've got it running here locally. We should be, I think we might have something up for you folks by maybe next week, maybe the week after, where like right now it's at a secret URL, so if you're like super sophisticated, you might be able to find this on the internet. It's on the internet now, but like we hid it, so good luck. You can't, it's going to be really hard to find right now, but we will make it available in the next couple of weeks. So what we did here is that this is my dummy account, so now you know how to get hold of me. That sucks. Whatever. Ain't like anybody watches this anyways. So cool. So I was going to give a status update. So we have our ingestion and picking engine running. So this is super cool. I haven't run the entire pipeline that brings in the information from the Securities Exchange Commission since it looks like the 13th, which was a couple days ago. I've been working mostly on the user interface, but check this out. So this is a cool feature that we had before. We've got it up and running again, and it runs every day, analyzes every stock across the entire freaking market. And I'm just realizing that this is probably out of sync, and there we go. Analyzes every stock from the entire market, and check this out. So we've got the actual scores bound up. So this is good because we have an easy score. So what's happening here? Let's just start with that. What's happening here is that we've broken every stock in the entire environment down into their sectors. We haven't gone deeper than sectors, but we've started, you know, healthcare, basic materials, technology. Then every stock gets its own individual score off of some basic stuff like, hey, are your earnings reports looking better? Is your earnings per share, is that increasing? Are you generating more revenue? Are you able to reduce your cost? What's your debt to income ratio look like? Where are you on like some of our technical indicator curves, like a MACD curve? We want to make sure you're on a growth spree. So basically what is happening is that sophisticated fancy pipeline where we're talking about all that like parallel processing stuff, it goes and figures all that mess out across the entire market. And then it finds and stack ranks every company. We give them a score. So there's a couple of main scores. There's a whole bunch of scores that we're hiding from you. We're not making those visible here, but we are making visible a few scores. And the main scores is the easy score, which is an average of the other three. The fundamental score, which focuses primarily on their financial statements. The momentum score, which focuses primarily on short-term technical indicators, and the risk score, which basically focuses on how predictable are you. So we got a lot of AI background. So yeah, you can kind of do some forecasting stuff, but that's kind of iffy. So what we focus on is like, do you follow enough patterns where your predictability is good? So a 1 is like your predictability sucks. Now, we haven't integrated all of the components of it yet, so kind of the only one that's really here right now is fundamentals. And we should have momentum and risk turned on sometime next week. And then the easy just averages all of them. So we do like an individual, how good are you? How good are you against your peer group? So you'll see that it's, this is the peer group. So just take your little bubble of circle of other companies who do similar stuff. Are you better or worse than them? And then we compare you across your entire sector. And then from there, everybody gets their weights, and then we stack rank all the companies top to bottom, and the folks who show up here are the best 3. So, and we do that every day. So that's kind of cool. I'm excited that it is like it's there. It's on the website that works. How cool is that? Other thing was that we wanted to go and make sure that we could show some of the backing information. So this one's Apple, and you can see some of the peers here. I should probably pick somebody. I forgot who it was. AA. Forgot who AA was. Yeah, AA. So Alcoa, they're a mining company. So this is a mining company. Here's their peer group. You can actually click on these and it'll take you to their analysis. It gives you all the scores here, but also we've gone ahead and given you all of their income statements that are reported annually. So these are SEC filed annual income statements. You can also get the quarterly income statements. And we've also turned on the balance sheet. So we didn't get we have all the details in our database. It's just like a lot of work to put it on the website. So we're kind of just focusing mostly on the stuff that people actually look at. If y'all think we should, put more information from their balance sheets and cash flow statements on there, then like we can totally do that. But we figured like doing that is really complicated and you're probably not using the site for that. So if you think it's interesting, we can invest more time there. And we haven't added anything here. So that's the update for, dang, my camera died. That kind of sucks. I hate when that happens midstream. You can't do live streaming on YouTube without a problem, can you? I've got a full battery and everything, I should have had a backup camera. That's what I should have done. That's because I'm at like 20 minutes or so, 30 minutes on this. It kind of dies off after 30 minutes. I bet it overheated. We'll see if we can get a live. All right, you get to see the... Wow, that's pretty rough. Let's try that again. That's back up and running. All right, well, that's the end anyways. So yeah, we kind of covered our news from the week. We had a couple little jokes, talked about our challenging thing, a little bit about parallel processing and the startup update. So hopefully y'all found that pretty interesting, and we'll see you next time.